Hello everyone, welcome to my channel. This is Bhupesh. Hope you're doing perfectly well. So today we're gonna talk about the OpenTelemetry Hotel Collector Auto-Instrumentation, which will help you to instrument any application for collecting the important monitoring matrices like rate, error, duration with the help of OpenTelemetry. We'll talk about how to get metrics and traces from an application and how to send the data to the Grafana LGDM stack. So we have done a similar session earlier, but using a Docker based approach, but we'll be doing today to completely on Kubernetes based environment. We'll be spinning up certain machines, certain images, especially the Python, .NET and Java images, and then we'll be spinning up containers on the basis of that, and then we instrument those containers with the help of Hotel Collector. It's a instrumentation kind that OpenTelemetry community has created in the recent past. We'll be using it and we'll be checking the same thing on our Grafana stack. We'll be going everything with this help of scratch. I mean, we'll be going completely scratch with the help of creating cluster and then implementing things one by one. So let's get started. We have a GitHub page also for that. I'll be showing those GitHub pages for this complete documentation. Let me show you the GitHub page I'm talking about. Yeah, so not this one. I'll be going to that repository. Yeah, hotel operator. Right. So this is the documentation, a very straightforward documentation that I've created for people who are new to this environment, Kubernetes environment, and so on. So let's get started. So what is the first step? First step is definitely to create a cluster. We'll be creating a cluster with the help of kind today, and not with the help of K3D. And then we'll be creating a cluster, and then we'll install the Cert-Manager. In that Cert-Manager will communicate with your hotel collector, hotel operator basically, and then hotel operator will instruct hotel collector to collect the data from two endpoints, OTLP endpoints 4317 and 4318, and this will act as an agent, right? And then we set up the instrumentation. And then we'll be setting up these apps, and finally after applications are set up, then we'll see the red matrices on Grafana Cloud. What we'll be using Kubernetes as a host platform. We'll be using Grafana for visualization. We'll be doing everything with the help of OpenTelemetry, and we'll be spinning up certain applications using Docker images and then pulling up. And we'll be doing a popular application called as Spec Clinic also today. So this is my cluster I'm talking about. Okay, so let me exit this. So this is all theory that we do. So this is the page I'm talking about. Okay, so first of all, I will create a cluster called as hotel operator with the help of kind. Kind can be installed with the help of brew or something, whichever you have in your Ubuntu machine. So you can install kind and then simply write kind create cluster -n and the cluster name. It will create everything, the control plane and the worker nodes and everything with the help of Docker images, right? So once this cluster is created, then we'll be installing the Cert-Manager with the help of Cert-Manager YAML files. So you can also see these YAML files of Cert-Manager like this. Okay, so this will get downloaded and this will downloaded here, right? So this is Cert-Manager. We are installing, we're first of all creating a Cert-Manager namespace, and then we'll creating a Cert-Manager custom resource definition. Okay, Cert-Manager is used to create certificates and manage certificate, the open source certificates, and it manages everything into the Kubernetes environment. So we can talk about Cert-Manager sometime later, but this Cert-Manager is used for doing the OpenTelemetry Auto-Instrumentation. Let's see why the cluster is ready. Yeah, the cluster is ready. And let me read the KTX. Yes, I am into that cluster. What all the namespaces are there? So we have all the namespace. I'm already into that cluster. So next is I will install this Cert-Manager via Helm chart. Now I'm installing the Cert-Manager now with the help of Helm chart. Right. So let me do a small. So Cert-Manager is installed. Let me see. Yeah, see, we have a Cert-Manager now namespace created, and the pods are getting created. So since it is a the Cert-Manager is getting created, the webhook pod is created, and see injector. This is a single node cluster, right? Let me see whether the Cert-Manager is ready with the help of this kubectl wait command, right? Okay, the condition is met, so my pods are running. Nice. So KNS, so I'll create create as matrices. I'll create a matrices namespace, and then I'm going inside this. So I'm into this now. Matrices namespace, so it is empty. Now, first of all, I will install the operator.yaml. Now, what is this operator.yaml? I will come here. Operator.yaml is nothing but the custom resource definition created by OpenTelemetry community, and you can use this for the auto instrumentation. So first of all, it will create a namespace called as OpenTelemetry system, and then it will create a CRD, and then whatever is there. So let me trigger this, and then we'll see what is creating it. So I will come to that location, cd hotel operator. Now I'm in this location, correct, and I can see the manifest folders. Yes, and I've not created all this documentation. I've used one of the block to create this documentation, right? Now, so I'll do KNS again. I can see the namespace has been created, and the namespace is giving you the pod is running, right? I can do kget all also in this namespace. You can see it is a deployment that has been executed, and there are a couple of services, and then this OpenTelemetry operator controller manager has been triggered with it is ready, right? With two containers basically. Okay, moving on. This is the operator. Now this is the second piece is the collector. Now what is the collector? Now collector is something. Now understand properly. Collector will collect the data from your applications. So you concentrate on this configuration. So configurations are same: receivers, processors, and your exporters, extensions, connector, service. So we are sending the traces, we are sending the matrices, right? Logs we are not sending it. Logs we are just OTLP and sending it to Grafana Cloud. So logs we are not doing it today. Logs will do it maybe sometime later, but we are doing only matrices and traces. Now it is going to the OTLP endpoint. Now how to get the OTLP endpoint? There are two ways. Either you can send this data directly to Grafana Cloud and get this OTLP endpoint URL, or you can send this data to Grafana Alloy, which is a agent on an OTLP endpoint, and from there you can send it to your individual LGTM stack, the local LGTM stack also. But that we will do it sometime in our next session. First of all, let me open my Grafana. If it is not login, let me just open. Okay, it is there. So this is my Grafana stack. I'm just showing how you can get the OTLP endpoint and the OTLP API keys, right? So I'll go to my stack. This is my stack I'm talking about, the Grafana Cloud stack. I'll come on to the OTLP section. Yeah, this is the OTLP section, correct? And then you can get the cloud instance ID is this ID, correct? You can see. So basically you need to change this ID, and then there's a API token, you can generate it from there. Then this is the cloud API key, and URL is this one. See, This is the same URL. So basically we are sending this data to the my bad. So I will do this again. Correct. So this is the OTLP endpoint, right? Which we need to copy paste. So basically you need to change three things. This is a Grafana Cloud OTLP endpoint, your key and the password. So what we are saying, please collect the data from 4317 and 4318 collector and then send this data to your OTLP endpoint. This is the collector. This is the normal, you can imagine as a agent which is collecting the data from the applications, right? So let me now go ahead and install this collector and then we'll talk about the instrumentation. We will install the collector. I'm into this namespace, I guess. Yes, so I will install everything in this namespace only. Perfect. So you see what all things has been collected. So this CRD has been created, this service account has been created, cluster will customer manage. So I will do get all again. So I can see collector deployment has happened. This total collector pod is also creating KGP. The total collector pod is now, you will see get service, which will expose this hotel collector service on two ports 4317 and 4318, by which we will send the application data to these ports. Correct. Now this is the third and the final instrumentation.yaml, which will make sure to instrument your applications. You see, this is the kind of instrumentation, and instrument your application, and then it will send the data of each application to this endpoint, right? This exporter endpoint, the hotel collector endpoint. So for Python, now we are providing certain other informations. For Python related, these are the two environment variables that get injected in each and every Python related application. So this is the hotel endpoint environment variable, and this is the name. For .NET, this is the thing. For Java, this is the thing. For Node.js, this is the thing. So for Java and Node.js, it is 4317. For .NET and Python, it is 4318. Deliberately, I've kept different ports just to make sure that data is getting, and it will propagate the trace context baggage B3. And yeah, this is the instrumentation kind that OpenTelemetry has created it. So we are actually, in the first one, the CRD things, we installed the cluster mining. Second thing is the collector, which will collect the data from application. Third is actually the instrumentation, which will do the instrumentation for us. Right, I'll go ahead and then I'll install this piece. Okay, so instrumentation is now getting installed into the same namespace. You see only one thing got instrumentation. I'll do this. Okay, you see my instrumentation has been installed, and this is the endpoint where it will send the metrics and traces. Sampler is one. Now we have a setup right now. We need to bring up the applications, right? So this is the next and the important step. Now let me go back. So we have certain, so again, this is the borrowed repository. So we have applications source code present in this repositories or the Docker file and everything. So first of all, I will create 3 images from scratch, Python, Node.js and .NET, and one I will use it the Java based from the Docker Hub. So first of all, let me build a Python image, right? Python image will get built. I hope it will not take much time because I did some time earlier also. So my image is ready. Node.js, it's a rolldice application. I think you might be aware about this rolldice application. Correct. So let me go ahead and build the .NET one also. Correct. So Docker images are created. Now I will load all these 3 Docker images to my cluster, right? So these images now is getting loaded from local laptop to the client cluster, so that I can use into my manifest for deployment and creating pod. Correct. So once these are ready, then I will simply go back and run this python.yaml, which will create a deployment, and then it will I'll talk about this annotations in a while, right? This will create a deployment and with one replica, one pod for this application, which will use the image which we just now created it. Now this is the important part, how it will do the auto instrumentation. So under annotations, these are the keywords that you need to pass. So instrumentation.OpenTelemetry.io injection Python, because this is a Python based application, so I will inject the jar file of Python here. I will inject the OTel platform, Python platform as MUSL, because it's a Linux based application. For Windows where you need to use something else, correct? So I think for this for other platform. Service name I'm putting a dice Python. You can give some other name. Namespace is game. You can give any other name. This is the service version, and this is the environment name. So these are the two important lines. What kind of jar you need to inject? Python. What kind of platform you need to put? This is the variable for name. This is the annotation that will make your application do the auto instrumentation using OpenTelemetry. Correct. I will move on to the metrics namespace now, where I will do all my application related stuff. I hope this is empty. There is nothing in this namespace. I'll come back to my documentation. First of all, I will do the Python based application deployment. So rolldice Python has been created. Then I'll create the Node.js and .NET also. Let's see. Yeah. So these three apps have been created. I will just simply see KGP. Now all three applications are running. I'll do port forward a little bit later. Now I have another applications, okay, which is actually pet clinic, which is not using any of the images which I created it today, right? It is using the let me do only one repair, which is using an image that is coming from a Docker Hub, Spring IO from a pet clinic, and this is a microservice based application, and I'm creating a service also. So let me run this pet clinic also, so that it gives a different flavor. I mean, you in place of this you can have any other of your application also. Okay, so I think I need to remove this. Where am I? Okay, I need to run it from here, so sorry. Yes, pet clinic has been created now. Your pet clinic pod is getting created and pet clinic service will be there. Perfect. So now we have a pet clinic pod and pet clinic service. Now before I go to Grafana Cloud, where I see everything, all the data, first of all I will generate some traffic from all these three applications, right? So I'll come to the Prometheus part, and this is the one. But before I do something, I'll generate some traffic. So first of all, let me access the pet clinic application. This is the pet clinic. So what I'm doing, I'm port forwarding my pet clinic service to the local laptop port of 4x1, which will redirecting it to the container port of 80. Simple as that, right? So this is my pet clinic application, and this is on. So I'm generating certain errors. Let me generate certain errors. These errors will come into the application monitoring of Grafana, right? So perfect. So I've done enough traffic hitting of pet clinic. I'll go back and then I'll do some hitting on my rolldice application now. KGP. Okay, I'll do port forward of now pod of what? The .NET rolldice pod. Okay, and for checking the .NET port, what is the port? I can come back here. I do not know the .NET port. I'll come here. I'll scroll down. 8083 is the port. Okay, 8083. I think I've talked about only Python, but for other Node.js based application, you need to inject the Node.js OpenTelemetry. See, for Java, you need to inject the Java related, and for .NET, you need to inject the .NET related. So these are the all four prominent technologies which we can do auto instrumentation, right? My .NET related pod has been exported now onto this namespace, port number. I'll do a roll dice endpoint. I can see the roll dice is now working. It is giving 2, 5, 6. I'm emitting certain traffic again on this application, the .NET based. This is the .NET one. Okay, let me go back. let me do KGP again, and let me do the .NET is done. I'll do the Node.js application hitting. Okay, what is the Node.js application container port? I'll come back here. I'll see 8084 is the container port. Okay, 8084, right? I have this time I've taken 4 times 3 as a local port and then roll dice, right? I can see the URL is giving a proper output. Now this is the Node.js based application that I've created certain traffic. Now I'll just go back and I'll do the Python based application, and I will choose something else. For Python it should be 8082. Let me not see the URL, the YAML, and it should work, right? Yeah, it is working. So you see, the Python based roll dice is also working. Now we have generated enough traffic onto our all 4 applications, all 4 that we have instrumented. Let me go back and see the next step. What we need to do, we need to go back and simply see the matrices that are going to my Grafana Cloud, because I've given a Grafana Cloud status or the matrices details, configuration details. So I'll see how many distinct matrix series I'm getting for last, I guess, 15 minutes. Okay, so I'm getting only Node.js for now, because this generally takes some time to get the data. Okay, so what I've done, I've re-deleted all the pods, and now the traffic is started coming. Now let me show you the in the application monitoring. You see the traffic is coming from all .NET, Node.js and Python based applications. So let me show you the even the pet clinic Java also. Show the Python based transactions are coming, even the traces are also coming. Yeah, let me go back and see the all other services, especially the Node.js, right? You see there are certain errors also, 100% errors are also coming in the application tracing. If I see last 30 minutes, there's nothing much on the last 30 minutes. Yeah, so that is pretty much yeah, you see last 30 minutes only Node.js has been done traffic generation. Prior to that it was the other aspects of it. So I mean, this was a little bit a lengthier session. I want to show how to set up the OpenTelemetry based auto-instrumentation and how to send the data directly to the Grafana LGDM stack. We'll take a pause here, and if you have any further doubts and queries, please note down into the comment section. But next time we'll be doing a more open source. We'll not use Grafana Cloud, and we'll send all this data to your local Grafana LGDM stack. And yes, we can see one more thing, a dashboard called as Grafana Bela dashboard that will give you the red matrices. If that is there, yeah, Bela red matrices. If I do it for last 24 hours, yeah, the BLM matrices are also coming. So let's wrap up for today, and how to take that dashboard, that is also being mentioned in this documentation. Okay, I'll take a pause. If you have any doubts and clarification, please note down into the comment section. I'll try to help and resolve most of your questions. For now, I'll take a pause and see you in the next session. Bye bye.